Record. All right. So the other day we did a pretty crazy topic. When you think of Unit 2, well, when you think of Unit 1, there was a couple of topics that were challenging. In Unit 1, it might have been the percent problem, if you remember. You had a mixture of a 30% and a 50% solution. Some of you maybe found graphing or system of equations difficult. In this chapter, this topic that we did yesterday is probably one of the, hardest might not be the right word, but there's a lot of work here. And the next section, so we did, you guys should definitely practice some of these, but the next section, topic 16, is a continuation of this. So it's really important, maybe this weekend, I know, you don't have an assignment or anything, you don't have a test. So maybe this weekend, if you have time, you might want to review factoring. I was talking to the other instructors this morning, and we've noticed that factoring itself is typically the issue here, not the steps after factoring. So maybe some of you, I'm not saying everybody, and you guys so far have been doing pretty good on, or most people doing very good on their tests. I'm almost done. But factoring might be a challenge. So the problem with math is it builds on itself. So if you can't factor, then you can't do topics 14, 15, topics 16. So before we get too deep in this course, well, we're already over halfway through, but before we get too far, just make sure, maybe take a couple hours Friday afternoon or Friday evening or Saturday and practice factoring, not fractioning, factoring. Because the big challenge up here with these questions we were doing yesterday was factoring. Before I get started with the new section, I also yesterday did a bunch of these questions here, but I erased them. I didn't save my workings, but I will post that YouTube video after this class. I forgot to post it yesterday. So there'll be the YouTube video for topic 15 and 16 after the class today. So definitely review them. All right, so where do we go from topic 15? We looked at simplifying rational expressions. Now, remember the difference between an expression and an equation. Okay, an expression is like when you just get a group of numbers or terms. An equation is when you have an equal sign. And we looked at equations all the way back in lesson 5 or topic 5. We looked at linear equations with one variable. We're going to do that again. They're going to be one variable equations, but we're going to make them a little bit more, I hate saying the word complicated, but like, we're going to add fractions kind of into the mix, or algebraic expressions into the mix. So one big important thing before I get into topic 16 is I want you to note the difference between something like 24 here. So like I have something plus something minus something. Okay, so look at that. It's like, 1 over w cubed plus 1 plus 1 over w plus 1 minus 2. It's missing something real. It's not missing something, but it doesn't have what makes something an equation. So we're going to look at two topics today. We're going to, I don't think it'll be as long as yesterday. We're going to look at how do we solve these equations. By the way, it's very much like what we did yesterday. And then we're going to apply it to something, because you guys are at like a technical college, so a lot of this information needs to be applied. So let's have a look. And I mentioned yesterday that I would kind of recover some topics from topic 15. I'm going to do that here because this is topic 15 with one little twist. So example number one is the quote easiest one. Maybe you don't find any of this easy, but number one here just is numerical lowest common multiple. I don't need to find, I don't need to factor. I don't need to do much work here. So first things first, and again, if you missed class yesterday, this is going to be very confusing to you. So make sure you check out that video. I'll have it uploaded after today or after class. The first thing you need to do is you need to find the lowest common multiple or lowest common denominator. For my purposes, it means the same thing. We're trying to find the lowest common multiple of the denominator. So we learned yesterday how to do that. So I won't spend too much time on problem one because we're trying to find the lowest common denominator of 2, 3, and 4. 2, 3, and 4. So think about it. Think of the multiples of 2. You have 2, 4, 6, 8, 10, 12. I could write that here, 2, 4, 6, 8, 10, 12. For 3, you have 3, 6, 9, 12, and 4, 8, 12. They all have a 12 in common. Okay, so in order to solve this, we need to get rid of the fractions. You can see that step right here. So what I'm going to do is I'm going to multiply both sides by 12 to clear these fractions. You guys actually had a question similar to this on your test. It wasn't as complicated as this because it was from a previous section, but you had to get rid of all the fractions in a number, and you multiplied everything by the lowest common multiple, which most of you did. So when I multiply everything by 12, and you can kind of skip this step here, you just multiply every term by 12. What that does is it allows us to reduce the fractions. So this would be a 6, or not reduce, remove the fraction. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. That's where these numbers here are coming from. Okay, so now look how easy this is. Imagine, picture this. If I asked you on the test number 1, to solve that, that's so easy. You put the x's on one side, the numbers on the other, and you get your answer. This is not needed, but if you ever have extra time, or especially when you guys are doing an assignment, you can check your answer by putting the number back in the equation. You don't need to do this. This is not worth marks. It's just, if you have time, if you were doing an assignment, this would be a really good idea. Okay, so, this was what we did in topic 5. This example was topic 5. So that actually is a review. In topic 15, we're going to make it a little more complicated. We're going to solve rational equations. We're going to solve equations that might need to be factored, or they might have an x in the denominator. So literally the only difference here is that the LCD might be a little different, like it might have an x or a y. And there will probably be factoring involved. So actually, guys, I'm sorry I didn't mention that. We did this question in topic 5. This question and the ones beyond it, so 2 and 3, these are more complicated because they are what we would call rational expressions. All right, so let's have a look at these. Now, as you guys know, I'm not a huge fan of doing these examples because the answers are already there. So I won't say quickly, but I'll go through these a little faster than I normally would. And then I'll show you some. We'll do some together. All right, so anyways, back to number 2. In number 2, we have this rational expression here. The problem with this one is that there's an X on the bottom, and I need to figure out the LCD of all of these numbers, the lowest common denominator. So again, a little review of yesterday. What common denominator could I use for 5x and 3? Well, the number 15 is my number if again, the lowest common multiple for 3 and 5. Well, 3, 6, 9, 12, 15, 5, 10, 15. So I know my lowest common denominator will need a 15 in it, but it also will need an X. So 15 and an X. Oops, sorry. Now, to get rid of fractions, right? Nobody likes fractions. I've never met anybody who likes fractions, maybe some crazy people. We want to get rid of the fractions here. So what we do is we multiply everything. And again, you don't have to do this step. Just multiply every term, right? There's 3 terms here. Multiply every term by that number. What that does is it allows us to remove these denominators. And we remove them by dividing or canceling. So 15x divided by 5 is 9x. 15x divided by x is just 15. And 15x divided by 3 is 10. Ooh, is that a typo? 15 divided by 3? That is a typo. I noticed a typo. What am I going to do here? Right, because, okay, before I go on, why is this wrong?
Multiply by 2.
Yeah, oh, you know what they did is they skipped a step here. Yeah. So, yeah, you're right. It is multiplied by 2. Thank you. So they're kind of skipping a step. Where did they get that 10? Well, 15 divided by 3 is 5. And then 5 times 2. So yeah, they're kind of, this book is like skipping a little step. It's not that they're wrong, but they're saying 15 times 2 divided by 3. So it is correct. Whew. That would have been bad if the book had a big mistake like that. Now, think about, I'm just going to erase my circles here. Think about this question. This is a pretty easy question now. I put the X's on one side, the numbers on the other, done, halas. And again, if you want to, you can always check your answer. You could put the number back in and see if you're correct. I'll probably check a few of mine today to show you how it works. It's a really good idea to check algebraic equations if you have time. Okay, now look at this. It's getting a little bit more complicated here. I want to solve this equation. 3 minus 6w over y plus 1 equals 6 over, or I said y, w plus 1. So again, I need that lowest common multiple that we were working with yesterday. Well, this one's a pretty easy one. The 3 is just over a 1. If you ever see a number without any fraction, in math, it's over a 1. So we don't really need to worry about him. Both of these guys have one w plus 1 term, or a factor, I guess you could say. So a big thing is you do not need to have your lowest common multiple as w plus 1 squared. Yes, there is 2 of them, 100%, but this is, you don't put them together. And the big thing to take away from yesterday's class is you're just trying to find something that each of them have in common, or could have in common. So as long as we have w plus 1, we're okay. You don't need to put the 1 there from the 3. So again, you multiply every single term by w plus 1. The goal here is by multiplying it by the lowest common multiple, you will get rid of fractions. Actually, now that I'm kind of doing this with you, I think this is easier than what we did yesterday. So you guys might like this a little better. We still will have to factor though. Don't think factoring is going away. And you'll see that in problem 4, I think. Okay, just remember your rules. For this, we're going to eventually, well, I'll do that step in a second, but 3 times w plus 1, there's nothing to cancel there. Okay, what about the second term? Well, with the second term, I can cancel these. You can see it in this step here. I can cancel those numbers. In the other term, I can also cancel those numbers. I really hope you guys can see the big picture here. By multiplying all of these by the lowest common multiple, you will get rid of fractions. Okay, so what happens next? Well, now we solve what's left. So distributive property, we multiply the 3 out, so it would be 3w plus 3 minus, watch out for your minus, 6w, and then equals 6. And again, this is a pretty easy calculation. Put the w's on one side, put the numbers on the other. Pretty easy. And again, I'm going to do some with you in a minute. Don't worry. Again, you can check your answer here if you want to. Okay, there's a little note here. Ooh. What is that? Okay, sorry. So I'm just reading the bottom. So we have w minus 1. It mentions here for checking this answer. When I check my answer and I put minus 1 in there, minus 1 will make a denominator equal 0. And there's actually something interesting about this. And not something I've maybe ever told you in this course, but you should have learned it before. I hope. You can try this on your calculators if you don't believe me. If you take any number on your calculator and divide it by 0, so anything, like you could say 5 divided by 0, your calculator doesn't know what to do with it. What my calculator will say is error. Dividing by 0 is not something you can do in math. It kind of like doesn't make sense to divide by 0. And what that means in mathematic terms is it's an undefined answer. There's actually no solution for this one. This would obviously, if you ever saw this, this is something that I wouldn't put on a test. Don't worry about that. But if you ever see an equation where you have to divide by 0, it's an error. It's no solution. There is no solution. So anytime in math, any number you can think of where you divide by 0, it's going to give you an error on your calculator. Okay. And then this just says what this just says. Okay. Let's do a factoring one. And then guys, again, I'm going to do some with you. So factoring, solve this equation. This is a good one. This would be a really good practice one. So 36 over p squared minus 9 equals 2p over p plus 3 and then minus 1. Okay, that looks crazy, right? And I'm asking you to solve for p. How are you going to solve? Like, this looks very complicated. How are you going to solve for p? Well, it looks complicated, but if I can come up with a good lowest common denominator and get rid of these fractions, I might have a good solution. Okay, so this one's gonna be a little challenging. We're gonna look at this a little slower, and then we'll do some together. First things first. Anytime you start a question, you always want to factor everything you can first. The ones above, like number 3, number 2, number 1, there was nothing to factor in any of these questions. There was no common term I could easily factor out. In number 4, I notice, and maybe it's just because I've been doing this for years, p squared minus 9 is a difference of squares. So what I can do is I can factor that. And by factoring that, it helps me identify the lowest common multiple a little easier. Because what you'll notice is that in order to get all of these denominators to equal the same thing, I'm going to need 1 p plus 3. I'm going to need 1 p minus 3. And then that's it. I mean, this fraction over here is just divided by 1. So this is my lowest common multiple or denominator, p plus 3 and p minus 3. So now, and guys, oops, sorry, I didn't mean to do that. This here looks insanely complicated, but it's really not. What's happening is we're multiplying every term by this number. And all you do is you make sure you cancel out anything that appears in the top, the numerator, and then again in the bottom, the denominator. If you do this correctly, every denominator will cancel. I should have mentioned that a bit earlier. Every denominator, I don't know if I have room, yep, should cancel. Okay, so if you set up your LCD correctly, every denominator will cancel. Now, this is where this gets a bit challenging, and we'll take some time to solve this today. For anybody eventually doing physics, you'll see this being applied to your physics courses. Once I cancel all of this information, I'm left with this. This still looks pretty challenging. So again, what you do is you multiply all of your terms together. Right, so here, I multiplied the 2p out, and then I multiplied these together. We're going to practice this today. I end up getting this term, or this equation, I guess, and I group my like terms, and here's what happens. I end up getting what's called a quadratic equation. I end up getting a p squared. When you're solving a quadratic equation, this one's a little different than the ones above. We're going to set all of the letters on one side, or like letters, numbers, everything. And then we're going to set the other side equal to 0. And we're going to factor and then solve. Now, how does this work? And don't worry, I'm going to show you some of these. How did we get from here to here? Well, p minus 9 times p plus 3 equals 0. So what you're going to do is you're going to set one of them equal to 0, and you're going to set the other one equal to 0. This is how you solve a quadratic. We're going to practice this. So when I solve this equation, I get p equals 9. And when I solve this equation, I get p equals minus 3. Now, here's a problem. I have two possible answers. I'm saying that p could be 9 and it could be negative 3. And this is, if I graphed a quadratic, you would see why. I can show you a graph in a minute. Actually, I can show you this graph in a minute. Don't worry, you don't have to draw quadratic graphs just yet anyways. So I need to see which one of these answers is true. They could both be true, or only one of them could be true. I need to check both of these and see which one works. So I check p equals 9. I put that into my equation. It works out. And what I mean by works out is the left side of the equation will equal the right side of the equation. P minus 3 also, or sorry, not also works out, doesn't work out. It has that 0 denominator, When you get a zero denominator, there's no solution. So we can eliminate p minus 3. Doesn't work. So the answer to this question is p equals 9. Now, let me just show you what this looks like on a graph. Let's graph this. And I've shown you this website before. I know we haven't graphed quadratics, but this is actually a good thing to do or learn, especially if you're going to go into physics. Sorry, I'm just writing down the quadratic here. Okay, I'm going to see what this graph would look like. Remember when we were solving systems of equations, you could solve them with graphs. You can also solve these equations with graphs. So let me share my screen. And again, this is not what I'm not teaching you how to graph this. You do not need to graph. I'm just showing you a really cool website that can graph things for you. This website, desmos.com. I do, like when I'm looking for this, I just Google the word Desmos. I typically use x for my variables. So the equation was p squared. So I'm going to say x squared minus 6x minus 27. And you can see my solutions here. Like, now, what do I mean by solutions? The solutions to the quadratic could be these points here. Oh, let me get my pen. So -3, 9. This is why, if you were wondering, why does a quadratic have 2 answers? Whoops, sorry. I thought my pen would scroll it with it. A quadratic has 2 answers because it crosses the x-axis 2 times. If you drew a straight line, so a straight line would be like 2x plus 2. A straight line only crosses the axes 1 time. All right, so quadratics, if you're wondering why it has 2, that's why. Let me get rid of my numbers as well and show you. I'll zoom out to what a quadratic looks like. Hold on. Right, so that's kind of what a quadratic looks like. You guys have probably seen these before, I would hope, in some of your high school math. I know in physics, a lot of times you would do, I'm going to make this real big. Let's try 50. Ooh, that's actually kind of nice. Oh, no. Let's make this smaller. I'll zoom in. In physics, you might actually use quadratics like this, you know, where it's like the path of a football, something like that. Oops. You know, something like that. I'm just kind of messing with the graph here. But you might see this in your future if you guys ever do physics. But this is called a quadratic. So I don't know if you've ever seen one or reviewed one before, but yeah, this is called a quadratic. Pretty cool. Anyways, I just wanted to show you that because I do find it interesting using this website. This is a fantastic website. If you go to desmos.com, sorry guys, I don't know why it's not taking me there. Something's going weird. Oh, I get it. Okay. So if I go to desmos.com, it has a graphing calculator, and it should have also a scientific calculator. Yeah, math tools. Sorry. So if you guys can see my screen now and you go to this site, it has a graphing calculator, a scientific calculator. If you guys ever get into matrices, it has geometry tools. We'll be doing that at the very end of this course. It's a really, really good website. Anyways, I encourage you guys to play with it. All right. So let's do some practice together. All right, number one. Well, let's start with an easy one. Well, not easy, but let's start with, the first practice question. I need to solve this equation. The problem with this equation is I have this denominator here that I need to get rid of. I need to get rid of the fractions. And I do that by multiplying by the lowest common multiple. So how am I going to find that? Well, before I do any of these questions, always look to see if you can factor first. So can I factor any of these? Nope. Can't factor that guy. Can't factor this. What about this? I wonder if I could factor him. I certainly can. I hope you guys, again, this is why you need to practice factoring. I can factor this as x outside of x plus 1. Okay, so let's rewrite this equation. 2 over x plus 1 minus 1 over x equals 2 x times x plus 1. Now you should start to see something. My lowest common multiple needs to have all of these terms. So I'm going to need at least 1 x plus 1. I'm going to need at least 1 x. This has both of them. So my lowest common multiple here is x times x plus 1. This is the lowest possible multiple that all of these things would have in common. All right, next step. Now, how am I going to do this? I want to use like different colors. So here, let me do it this way. So now I'm going to multiply both of these by my lowest common multiple. So I'm going to multiply this by x times x plus 1. Okay, then I wish there was a way I could change colors quick, but anyways. Then I'll do this one. Multiply this one by x times x plus 1. And then I'll do the other one. I think I'm writing too big, by the way, but we'll see. So 2 over x times x plus 1. All right. Now, the best part about this, sorry, I'll move that over. The best part about this is all you need to do now, and this was always my favorite thing when I was younger, is to cancel any like terms. So they cancel, these cancel, this whole thing cancels here. So let's write what's left over. Anything I didn't cancel, I'm going to write down. Okay, so here I have a 2x. Here I have a negative 1 times x plus 1. And here I just have a 2. Now, guys, just take a minute and think about this. This is a pretty easy equation now to solve. So the only, or I shouldn't say the only hard part, but the difficult part is getting to here. Although we haven't, I'll do a quadratic with you soon. So I'm not done yet, though. I still need to solve. So I'm going to simplify this to x minus 1 equals 2. So this would be x equals 3. Remember, I moved the 1 over. And that's it. There's my answer. 2x minus x is just 1x.
Yes, sir, minus 2.
Wait. Did I leave out a negative? Oh, I did.
Yeah.
Yeah, sorry. Thank you for that. That's actually a big help. Guys, I didn't see this. I was writing on it in pen. There's a negative here. This little sneaky negative. That's why you got to be careful. It won't really change, it'll change the answer, of course, but at least it won't affect much of the workings I did. Thank you for that, though. If I could give out bonus marks for that, I totally would. Okay, so now what we get is when we move this guy over, we get minus 2 plus 1, which is a 1. Whew, that's a nice, pretty answer. X equals 1. Okay, now we can always check our answer. Let me
Yes, minus one. Mr. Minus one, I mean.
Yes. Oh, yes. We can always check our answer, and I want to pick a different color for that. Let's go purple. I never use purple. Let's check our answer here. So -2 plus a 1 is a -1. Let's check that. Now, how do you check these? What you do is you take your original equation and you put in that number you just solved for. Okay, so right here, I'm putting in a -1. So -1 over -1 equals -2 over -1 squared plus 1. Now, what you'll notice is we're getting that denominator equaling a 0 again. And when the denominator equals 0, this means it's anytime your denominator is 0, this means it's undefined. So no solution. So if you did this on, say, a test or something like that, you do need to show me x equals -1. You would need that. And then you would show me if that number was actually possible. And this is undefined, no solution. All right, I'll do a couple more. Don't worry. That's all right. I'm just opening the chat here. I have a private message in the chat here. It says, I don't get how we got x times x plus 1. Do you mean, well, okay, that could mean two things. So before I move on to the next question, let's look at that. I factored this guy over here, and by factoring, I removed an x, which left me with x plus 1. Now, you might also be asking, how did you get x and x plus 1 for the lowest common multiple? Well, or lowest common denominator. It's again, I kind of use those interchangeably. I'm saying the lowest common multiple of the denominator. Well, we only need a multiple that includes every denominator. So my denominator here has x plus 1. This one has x. And this one has both terms. So as long as we multiply everything by x times x plus 1, we will remove all of our denominators. Okay, and again, if you're up here, if you're wondering where it came from, I just factored. And I mentioned this at the beginning of class. You guys really, like, if the factoring is a problem, you will have so much trouble with topics 14, 15, 16, which is fine now because they're not, we're not doing an assignment. There's no test yet. But you need to know how to factor before test number 2 or even assignment number 3. All right, let's do another one. Let's do another one together. Actually, I was going to say let's do another one together. I am going to do more of these, but why don't I zoom out? Sorry, my writing's a bit messy there. I'll try to write a bit neater for the next one. Why don't you guys try this one? And the reason I say that is because it's very, very, very similar to question number 1. So you would use the same method. You would factor, find the lowest common multiple, and then simplify the equation before you solved it. So try this out, and I'll give you a couple minutes for this one. And then again, of course, I'll show you some more complicated ones. So yeah, good luck. The good part about this is when you guys tell me the answer, you can just say like x equals 3 or something. So it's easy to type into the chat if you can get it. All right, so I'll be back in a minute. Good luck. Ooh, I got one answer so far. That's awesome. I think that's correct. Fatima, keep trying, everybody. These take some time, so I'll give you guys another minute or two. And then we'll see if it's x equals 2. Hopefully I won't make a calculation mistake, and we'll see if there's no solution when we check it. So take another minute or two, finish it off, see what you get. Okay, let's have a look at this. Okay, so let me zoom in here. I'll try and write a little neater here. Okay, first things first, again, every time you do one of these, start with factoring. Or I mean, like, see if you can factor anything. And I know for this guy here, I can factor. You can't factor just x. You can't factor just x minus 2. However, I can factor x squared minus 2x. I can take away, and not take away like subtract, but remove an x from both terms. So that leaves me with x times x minus 2. Okay. So let's rewrite this equation. Go back to red. 10 over x outside of x minus 2 equals, or sorry, not equals, minus 4 over x equals 5 over x minus 2. Now what I need to do is find the lowest common multiple or the lowest common denominator for all of these terms. So what do they all have in common? Well, you know, this has an x and an x plus 2, or sorry, x minus 2. This guy has an x, so they have this in common. And this guy has x minus 2. So that means if I can multiply every equation here by x minus 2, I can get rid of those fractions. Again, this is the goal. You want to get rid of all of these fractions. So I'm going to rewrite this now. So what I'm going to do is, it's a lot easier if I was on a whiteboard in class, but anyways, I'm going to multiply this guy on the left by my LCD. Okay, or LCM, you know, same thing, really. Oops, sorry. Okay, then I'm going to subtract the 4x and multiply him by the LCM or LCD. Okay. And I'll do the same thing for the other guy. You have to do it to everything. Okay, so now what I'm going to do is I'm going to cancel anything that appears on the top and the bottom of each term. So that's awesome because I'll go green. This cancels, and this cancels. So what I do is I write down what's left. It, like, you know, it's a lot of writing, but the steps aren't difficult. It's just a lot of writing. So what I'm left with is 10 minus 4 times x minus 2 equals 5 times the x that's left. This, and now please, if I make a calculation mistake, let me know. This is now I shouldn't say very easy to solve, but you know, this is stuff we did back in topic, I think 4, topic 5. So 10 minus 4x plus 8 equals 5x. So now I'm going to solve for x. Okay. I guess the easiest way to see, I'm such a fan of having x's on the left and numbers on the right, but really it probably would be easier just to move him over. So we would get 10 plus 8, which is 18, and this would be 5x plus 4x. Remember, sorry?
2 over 9, x equal 2 over 9.
I don't think it's 2 over 9. It would be 18. Well, you'll see. So I move this over. I get 4x. I was going to skip a step, but I won't now. So I'll get 18 equals 9x. And now I just solve for x. X is 18 over 9, or x equals 2. Okay, I did like every step there. You guys don't need to show me all those steps, but 18 divided by 9 is 2. Every time somebody writes me in the chat when I'm, thank you, Amar. When I'm teaching and somebody writes in the chat, I always like panic for a second, you know, oh, did I make a mistake? But no, x equals 2. Okay, now let's see. Let's see what kind of solution this will give us. So I'll go back to purple. Let's just see what happens when I put x equals 2 into this equation. All right, so sorry, I had to go back and look at the original equation. So 10 over 2 squared minus 2 times 2. I think that's where my problem's going to be. Minus 4 over 2 equals 5. 2 minus 2. Again, I'm getting zeros in my denominator. Whenever you get a 0 in denominator, there is no solution. Cool. Not easy. You know, I thought when I was reading the notes before we started, and I was like, we're gonna fly through this. This will be no problem. But now that I see it, maybe it is a little trickier. Okay, so give me 1 second. I wanna pick a good one to do with you guys. So just give me 1 second. I want to see something. Okay. What I'm going to do is I'm going to look at the.
Mister, do you
Yes?
have to check and put equals 0 and decimal or 0?
I don't know where you're. What do you? Oh, denominator 0. Yes.
Do I have to check now?
Yes.
Okay, thank you.
No problem. Okay, give me 1 second here. I'm just looking something up really quick. Okay, cool. Sorry, I just wanted to see what kind of question I wanted to do next. Okay, let's go a little deeper so you guys can practice some of these. Let me go a little deeper here. Sorry, I just want to see how far down we're gonna go. Whoa, there's a lot of practice you guys can do here. Oof. Well, I guess 12 questions. So let me pick one in the middle, and we'll see what we get when I do one in the middle. Okay, let's try number 9. Let's look at number 9 together. Okay, so same thing. And now you'll notice that this equals 0. That won't affect anything yet, so everything's good. Nothing's changed. We're still going to try to get rid of the denominator. We're going to see if I can factor. And then if I can factor, I'm going to simplify this as best as I can. Okay, so I cannot factor x plus 3. I cannot factor x minus 3. But I can factor this guy. This is, and you'll see these a lot. These are kind of like a math teacher's favorite ones, a difference of squares. So I'm going to try and factor 4x squared minus 36. Okay, and see what I get there. Now, there's a few ways you can do this, but what I would do first is I would factor out my 4. So I would get x squared minus 9. And then what I would get, this is a difference of squares. I would get 4x minus 3, x plus 3. Okay, again, very, very, very important that you guys review factoring from topic 12. Topic 12 was a big one. All right, now I'm ready to go. What I need to do before I go any further with this question is I need to rewrite my denominators. So 1 over 4x minus 3 and x plus 3 minus 5 over x plus 3. I'm talking to myself, but I always do this in my head, at least when I do questions, and that equals 0. All right, lowest common denominator, lowest common multiple here. What do all these have in common? Well, the 0 is just a 0. So the 0, it doesn't have a denominator. Well, it does. It's over 1. I don't need to worry about the 0 for my lowest common multiple. I'm worried about these numbers here. We have a 4. We have an x minus 3 and an x plus 3. I also have an x plus 3, so I can keep him, and another x minus 3. So my lowest common denominator or multiple will need to have a 4. It will also need to have at least one x minus 3 and one x plus 3. That means every one of these should eventually cancel. Okay, next step. Multiply every number by that LCD. Ooh, this is going to be a lot of writing. Okay, so first things first, I'm going to multiply the first term by 4, x minus 3, x plus 3. Okay, so I'm just writing this out. This takes so long because I have to like write everything out. It's a lot of writing. It looks really scary, but once you practice, it's not so bad. And there are ways that you guys, or not ways, but some of you guys, when you're more comfortable with this and you've practiced this, you don't have to write all of these steps. I'm just showing them to you because, well, we're learning it for the first time. Some of you might have done this in high school. I know if you were in like a British or Canadian American system, you would have done this in high school in some level. Okay, whew, and that equals 3. Or sorry, that equals 0. Now, I'm not even going to bother multiplying the 0 by anything because, guys, remember, 0 times any number is 0. I kind of ran out of room over here, but anything multiplied by 0 is 0. So no matter what, this is going to equal 0. Okay, so cancel time, my favorite thing. All of this cancels. Beautiful. The x plus 3 cancels. Beautiful. The x minus 3 cancels. And I write down what's left. So much work. Okay. So I end up getting 1. You have to keep the 1 there. Minus 5 times 4 times x minus 3 plus 2 times 4 x plus 3 equals 0. Okay, so I'm going to get 1 minus 5 times 4. I guess I'll go pretty slow through this. This equals 20. So what I'm going to get is 20x plus 60. I'm thinking like maybe I should show you where that comes from. Okay, I will show you where that comes from. So what happens is I multiply 5 and 4 together. I still have the negative 20. And then I'm going to multiply the 20 in here. So that's where that comes from. When I multiply that together, I'll get 20x, but this and this become positive. Okay, let me check the chat before I move on. Oh, somebody already gave me a solution. Okay. Ooh, if that's the solution, somebody wrote me a private message that this is a complicated question, but there's no problem with that. It's a good to do in class. Okay, I might as well keep it like this. I'll write it out nice and slow and steady here, showing all the steps. So I'll get 1 minus 20x plus 60. Careful with that. Plus 8x plus 24. All right, almost done. Now I need to combine my like terms, and I'm going to put the x's on the left and the numbers on the right. Okay, so I'm going to keep these here. So this would be negative 12x equals, or sorry, let's keep it like this. And then I'll combine my numbers. So I'm going to get 1 plus 60 plus 24. So 1 plus 60 plus 24. And that gives me an 85 equals 0. So negative 12x equals negative 85. X will then be negative. I'm going really slow. Not slow, I guess, but I'm showing like every possible step here. 85 over 12. And since I hope we all have those Casio calculators, that's it. That's my answer. So X equals,
Positive.
sorry?
Positive.
Yes. Oh,
So
yeah. Positive 85 over 12. Yep. Exactly. Okay. Whew. That's not very pretty. Normally, math people try to get this to work out really a little bit better than that. This one's not very pretty. I can tell you one thing, though. If you check this, let me pick a different color. Oh, sorry. What color? Purple. Stick with purple for checking. If I check this, I know there's no way I'm going to get a 0 in the denominator. Now, how do I know that? Well, look at the original equation. I'm going to put in this number. So 1 over 4, 85 over 12 squared. You could use a decimal if you wanted to, minus 36, minus 5, and then 85 over 12 plus 3. Plus, I'm running out of room here, sorry guys, 285 over 12 minus 3 equals 0. And you can try, well, I mean, you can try this yourselves, but there's no way that these denominators will equal 0. Okay, I'm going to kind of save myself some time here, but you can check these on your calculators. These denominators will not equal 0, so this is a solution. Again, I'm just doing this to save myself time. None of these equal 0. And you can check them on your calculator if you want, but there's no way. Okay. Oof, I didn't like that one. I picked it because I thought it would be a little bit better than that, but it wasn't very, I don't know, wasn't very good looking. Okay. Trying to think now. What do I want to do? I guess I could show you one more, but do you guys want to see one more before you practice? Because we haven't really seen one of those quadratic ones yet. Maybe let's look at one more. Okay. So I just got to pick if I want to do number 11 or if I want to do number 12. Let's just see here. Oh, now my computer's a bit slow loading. All right, page 55. Okay. Sorry. Yeah, I'll do 11, and then maybe you guys can try 12. Let's do that. Okay. So let's do one more. Or let me do one more with you. Okay, so as always, factor, factor, factor. So I'm going to factor here. So 3x, sorry, I'll write the word factor. Now, nothing I can do with x plus 1, but I really think I can simplify 3 and 6. So, 3x plus 3 and 6x plus 6. So let's look at these. 3x plus 3. I can totally factor that. I can pull out a 3 and I get x plus 1. That's nice. What about 6x plus 6? I can factor out a 6. I get x plus 1. That's pretty good. Okay, so now let's rewrite this and let's worry about our lowest common multiple here. All right, back to red. So negative 5x over 3x plus 1 equals 2x over 6x plus 1 plus 2x minus 4 over x plus 1. Okay, very easy looking LCM or LCD here. Well, I'm sorry, I shouldn't say that. This is an easier one than some of the others. What I need to do to find that lowest common multiple or denominator is first, I see numbers here. So first things first, I need to think about what is a number that 3 and 6 have in common. Well, I immediately know that that's going to be 12. How did I get that? I'm going to erase this, guys, but how did I know that this is 12? 3, 6, 9, 12, 15. These are the multiples of 3. So 3, 6, 9, 12. The multiples of 6 would be 6, 12, 18, and you can go on, but I know that 12 is that magic number here for the 3 and the 6. Okay, so let me get rid of this. I'm not trying to get rid of it to confuse you. It's just I don't want to waste room. Now the other thing about the LCD is it can't just be the 12. I also will need this x plus 1. So the LCD will be 12x plus 1. I'm going to multiply everything by 12x plus 1. This example, I think I like better than the last example. So 12x plus 1 multiplied by negative 5x over 3x plus 1 equals, okay, so I'll put that 2x there. Oops. Then I will multiply that by my lowest common multiple. Okay. Oh, I'm getting close to running out of room. And then I'm going to add this guy and multiply that by my lowest common multiple. All right. Cancel, cancel. So back to green. Let's cancel what I can. So x plus 1 and x plus 1 will cancel. But notice that when I go 12 over 3, that doesn't actually cancel. That will leave me with a 4. This guy over here, the x plus 1's cancel. This guy here, the x plus 1's cancel. So I'm going to write down what's left. Now be careful again. The 12 and the 3 will reduce, and the 12 and the 6 will reduce. This 12 stays. So I write down what's left. 12 times a minus 5 x. 12 times minus 5x. I'm going to use brackets here. So I get 12 times minus 5x. Not 12. 12 divided by 3 is a 4 times minus 5x. When I was a student, I'd always make mistakes. I'd always make stupid, silly, I shouldn't say stupid mistakes. That's very rude. Silly mistakes. I'd write this down and then I wouldn't cancel them. So just be very careful. Here I'm going to get 12 and 6. So that will leave me with a 2 times the 2x. And here I'm going to keep the 12 in total, because that didn't cancel with anything, and multiply that by 2x minus 4. All right, this is looking a little bit better now. So minus 20x equals 4x plus 24, not 12. X minus, I'm making sure I got the minus right, minus 48. Okay, whew, this is looking okay. Now, put the x's on one side, your numbers on the other. I guess what would be the easiest way? Again, you guys know I like to have my x's on the left. So yeah, let's do that. Let's move the x's over to the left and we'll keep the number on the right. So I'm going to get negative 20x minus 4x minus 24x equals a negative 48. We're so close to being done, guys. So put all this together. Minus 20 minus 4 minus 24. This is going to look a lot nicer in a second once I have all of this calculated. Because when you do all this, you'll get negative 48x equals negative 48. And this is kind of what I meant a few minutes ago when I said a lot of times they'll look a lot nicer than number 9 because now x is just going to be a 1. Whoa, all that work just to find out that x is 1. Now, is it going to work? Will we get a solution for this? So I'm going to go back to the original question and see if that x equals 1 will work. Okay, any questions so far? All right. So let's check. Yes?
Why it couldn't be LCM 6 rather than 12? Because in 3 we have 6, in 6 we have 6.
Yes, that would have been, I could have made it lower. I could have, actually, yes, that would have worked, but this also gave us the same results. But yeah, that's a good observation. I could have actually just picked 6 for those two.
It will be same x?
Yes.
Yes.
We'll still get the same answer. That's the beauty about the LCD. Once we work it out, it will still get the same answer. All right, so we're going to check this. Okay, I find this hard because I got to keep scrolling around. So negative 5 times 1 over 3 times 1 plus 3 equals 2 times 1 over 6, 1 plus 6. 2, oops, didn't mean to put
plus.
Thank you, good eye. 2, 1 minus 4, and then 1 plus 1. Whew. All right, let's check it out. So negative 5 over 6 should equal 2 over 12 plus negative 2 over 2. So negative 5 over 6. Let's see if it equals this guy over here. And again, I'm going to do this on my calculator because we have really nice calculators that can simplify these fractions for us. So 2 over 12 plus a negative 2.
Same.
2. Sorry, I didn't hear you.
The same.
Same. Perfect. Negative 5 over 6. It worked. We have a solution. We knew that none of these denominators were dividing by 0. So this is our solution. X equals 1. We did it. Whew. Okay. So it's definitely getting late. Like it's 3 o'clock. Class ends at 3:30. And I know we've done a lot today, but I really think it would be beneficial if you guys took the time instead of just leaving. I know it's Thursday afternoon, but I really think you should try one. So why don't you try number 12? And we will, or I'll do the answer with you, and then halas, we're done for Thursday. So again, I know it's been a long one, but let's get you to try one more for practice and see if you can get the answer for number 12. All right, so I'll put myself on mute, and if you have any questions, let me know, and we should be done within 10 minutes. I'll give you guys 5 to try it, and then I'll take 5 to solve it, and that's it. Okay? Be back in 5.
I think x equals 0, something like that.
Okay, that's good. And you know, we can have x equals 0. That is a valid solution. If, however, the denominator equals 0, and that's a hint, hint. If you look at the 1 over x, see the middle term there? If that denominator is going to equal 0, then we have a problem. So, you know, just because x equals 0, don't think that there's no solution. But, and I'm kind of foreshadowing here, if you do look at that equation, there might be a situation where we have a 0 in the denominator. I do think you're right, though. So just take two or three more minutes. I really want everybody to try this, and then that's it. I'll do the answer, and we're done. All right, let's say a minute or two more. I did also get a 0. This is a good one for you guys, actually. I thought I was being evil and making you do the last practice problem, because typically the last practice problem is the hardest. This one's not bad. So just take another minute, and I do think it's 0. And you can let me know in the chat if you also got 0, and then we'll check to see if that's a solution. So one more minute. Okay, let's do this one. Actually, and guys, this is like, hold on, now let me get my pen working. This is a good way to kind of cap off the week. It's been a crazy week for you. You had midterms and a math test, not a midterm. And we've had some long classes. This is a good one to finish with, because when I worked through it myself, this is a pretty straightforward question. It's certainly a lot easier than number 9. And arguably even easier than number 11. So this is a good example of what they can or what they will look like. I've told you this before, but some of the examples in the book are a little evil. They're, meant to challenge you. This is a good one to finish off with. So I've said this 50 times today. If you can, start with factoring. And one thing I want to mention is it might look like you can factor 2x minus 3, but you cannot. Like there's nothing in common I can remove. I can't take out a 2. I can't take out a 3. So nothing I can do there. However, I can certainly factor this guy on the left. 2x squared minus 3x. This is excellent because, straightforward factoring, I'm going to remove the x. So 2x squared minus 3x, I'm going to remove that x, and you'll be left with 2x minus 3. And like, the more you practice this, the more you guys will see what I see. It's kind of like, that meme where like you see the guy's face and there's all these calculations behind his head. When I see this, things start to move in my head, because this 2x minus 3, I see it somewhere else. So now I'm already thinking a step ahead. I'm thinking this is looking good. My lowest common denominator is going to be simple. It's going to have all of this in common. And we try to create math questions that are like this. So, seeing this instantly made me happy, because when I write out the next step, which I actually, at this point, I probably don't need to write this step out, but I will. When I write out the next step, give me a second. My LCM gets a little bit more straightforward. The lowest common multiple, or denominator, you guys know I kind of say that interchangeably, the lowest common multiple of the denominator has to have an x. It has to have a 2x minus 3. So that's it. X times 2x minus 3. Okay, So let's write it out. Let's multiply every term by this. X 2x minus 3. Okay, and then I'm going to change my pen color here back to red, and I get 3x 2x minus 3. Now, for some of you who are really understanding this, you can skip a lot of these steps, especially this one, because I mean, I know that these are going to cancel. So you don't have to show me everything if you are comfortable with this. For the students who might not feel comfortable with this, I have 2 suggestions. Definitely practice factoring and definitely write every step. It really helps visualize math if you write everything down. So almost done for today, and then you guys get to enjoy your weekend, and hopefully you don't have any midterms or upcoming tests to worry about.
Forget an X.
Did I leave an X? Because I'm talking. Did I leave an X out? I did leave an X out. This X right here. All right. So thank you for that, by the way. I need you guys to keep me on my toes because talking and writing is hard. Okay. I'm going to cross out everything that's on the top and on the bottom for each of these terms. So goodbye. That makes that really nice and easy. Get rid of these X's and get rid of the 2x minus 3. So this turns into quite a beautiful little equation, if I do say so myself, because I'm going to be left with 3 plus 1. Now, guys, you don't actually need the 1, but you know, for anybody who needs to see every step, this will help. But you don't need to write the 1 in this situation. And that's going to equal 3x. Okay, now I'm going to distribute the 1 out. Again, that's what I mean. You don't have to write the 1 because all I'm going to get is 3 plus 2x minus 3 equals 3x. All right, we're so close. Now I'm going to move the x over. So I'm going to get 3 minus 3, 0 equals x. If you're wondering where the 0 came from, 3 minus 3 is obviously 0. If you're wondering why I just wrote x, it's going to be 3x minus 2x. So just simple x. All right. Now, this is good. This is your answer, and you need to show me this on a test. But is it a solution? I can tell you right now, this is not going to be a solution. And it's all because of the middle term. So I don't even need to write all this out to know, but I will. 3 over 2 times 0 squared minus 3 times 0. So that's going to be a 0 plus 1 over 0. You know, the alarms should be going off now. And then 2 over 0 minus 3. Alarms, alarms, alarms. No solution. I'm dividing by 0. So I have a denominator equal to 0. No solution. I had a student ask earlier, do I need to write this down? Like you actually, you know, you don't need to write all of this down. Like you don't need to say denominator equals 0. You don't need to actually tell me that. As long as I know that you've checked this to see if there is a possible solution. And just for anybody who might have spaced out, the reason there's no solution is because you cannot divide by 0. And if you don't believe me, take any calculator, take your phone, take your Casio, any calculator, and take any number you can imagine and try and divide it by 0, and it will say error. It's not possible. Oh, what a class. What a week. Okay, so that's it. Guys, I as I told you in the post this morning or this afternoon, your test marks will be on in the grade book on PeopleSoft, not on D2L. It'll be on PeopleSoft, like the college's website, after this class. I just need a little bit of time to finish adding up some numbers. So in maybe an hour or so, your marks will be available on the college website, the PeopleSoft, how you check your marks in most courses. They're not on D2L because you did it in person. So I'm not going to upload them to D2L. Okay, so that's it for me, everybody. I'll upload these videos as well. I'm missing yesterday's video on YouTube, so I'll have that uploaded as well as today's lecture and give YouTube some time to generate it, but that'll be up soon too. Okay, any questions, let me know. Other than that, have a good weekend.